Hi to the host students, Mr. Kaczynski with you. Practice your skills 6.3, multiplication and exponents. Let's get all over it. Here we go. All right, we're supposed to simplify these expressions. All right, so I got a 5, and then I've got 1, 2, 3, 4 x's. So how about 5x to the 4th? We're also instructed to check our answer on the calculator. There's a couple ways you can do that. First, I think I like this way better is 5x to the 4th. It's got its limits though. We'll talk about that tomorrow in the reason and apply. 5x to the 4th. And then we've also got the original, which is 5 times x times x times x times x. Don't need the parentheses. That's just a waste of our time. And if we check the table, we can see it gives us the same table both ways. All right. The next one, I'll check a different method, okay? All right, so we got a 3 here. And again, how many x's do we have? 1, 2, 3, 4. This is 3x to the 4th. All right, so let's check our answer here. Well, let's go this way. Let's just assign a random value like 5, and we'll store it. Here's the store button, as x. And this says that when you do x times x, and then you multiply it by 3 times x, you'll get 1875. Whereas if you just do 3x to the 4th, you'll also get 1875. Now, even if we change the value of x, say we make it -2 and we store that as x, and then we ask it to do the original expression, it'll give me a different value. However, when I use that -2 into the simplified expression, I get the same different value, if that makes sense. All right, moving on. 2 times 3 times 4. 3 times 4 is 12. Doubled is 24. How many x's do we got there? We got 1, 2, 3, 4, 5, 6. So x to the 6th. Oops. 24x to the 6th. Let's check that. 2x, 3xx, 4xxx. There's unsimplified. And I think we like the simplified version better, and it is equivalent. All right, 3 times 5 is 15. X to the 4th times x to the 6th is x to the 10th. When you're multiplying numbers with the same base, you can add their exponents. Now, 3 and 5 don't have the same base, but they have the same exponents, so we can multiply those. All right, let's check that. Let's use the y equals. All right, 3x to the 4th, I got to press to the right, times 5x to the 6th, and 15x to the 10th. Check the tables. You get the same tables. Check the graph. You get the same graphs. You can barely tell what's there. It's a really skinny parabola. All right, so I always use the table. Like that. All right. 4 times 2 is 8. X to the 7th times x to the 3rd is x to the 10th. 7 plus 3 is 10. That's where I'm getting that, okay? We'll prove why here on the next problem. Checking our answer, 4x to the 7th times, I would definitely be checking my answers, man. If I'm doing a checkup or something that's graded, I'm definitely going to check my answers. Check the tables. They are the same. Great. And 3 times 1 is 3. And x times x, or x to the 1st times x to the 1st, times x squared. 1 plus 1 plus 2 is 4. So we'll call this 3x to the 4th. Let's check it. 3, you know what? Let's go back to the main screen. Let's do this. 3x times x squared. And 3x to the 4th. Same thing, 30,000. Let's go to here, and we'll go 3 times x times x times x squared. And here we'll put our simplified 3x to the 4th. Check the table. Gives us the same tables, and you'll notice here, what did I have entered in for x? Now I don't remember. Thought I had -2. Let's check. What did I have entered in for x? Oh, I have 10? Well, how did that get there? There's the 30,000. There it is. All right, moving on to number 2. Write each expression in expanded form, then rewrite the product in exponential form. So we're going to do expanded form, and then we're going to do exponential form. I'll color code these. So expanded form, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. I never want to have to do that again, but I'm going to have to. How many of those are there? Well, there's 5, and then another 8, so there's 13 of them. All right, B. Got these right on top of each other now, but I'll make room. 7 times 7, that's 7 cubed. 7 times 7 times 7 times 7, that's 7 to the 4th. Together, they equal 7 to the 3 plus 4 is 7th power. X to the 6th, that would look like this. There's x to the 6th times x squared. So what do we have? We have x to the 6th times x squared. That's x to the 8th. Y times y times y times y times y times y times y. I've lost count. 1, 2, 3, 4, 5, 6, 7, and 8 times y times y, 2, 3, 4, 5. Ooh, should have set this up a little differently in this notebook. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. That would be y to the 13th. Give myself a little bit more room here. All right, this one, we're going to call it 1 minus 0.07 times 1 minus 0.07 times 1 minus 0.07. There's 3 of them. So we've got the squared and then the first power. That's going to be 1 minus 0.07 to the 3rd. I would not blame you for fast forwarding right now. This is very repetitive, isn't it? This is why we use exponents. 1/2 times 1/2 times 1/2. There's 1/2 to the 3rd. 1/2 times 1/2 times 1/2. There's 1/2 to the 3rd again. So 1/2 to the 3rd times 1/2 to the 3rd is 1/2 to the 6th, because there's 6 of them. All right, now it gets a little interesting. We got a 4 times x times x times x times x times x times x times x. So we've got the 4, that's just to the first power, times x squared times x to the 5th. That's 4x to the 7th. 4x to the 7th. This one, 4 times x times 2 times 1, 2, 3, 4, 5. So what do we got all together? We got the 4 and the 2, which makes 8. There's a couple different ways to think about this, actually. And then we got the x squared times the x to the 5th, which is x to the 7th. You know, another way to think about it would be, you could make this 2 squared x to the 7th, and you could make this 2 cubed x to the 7th, because this is like 2 squared, and 2 plus 1 is 3. Not sure that's really what the book's expecting, though. All right, last one of these. X times y times y times y times y. That's x squared y to the 4th. And then times x times y times y times y. That's x times y cubed. So altogether, we've got the 2x's and the 1x, which makes x cubed. And we got the 4y's and 3 more y's, which makes y to the 7th. So that's exponential form. All right, rewrite each expression with a single exponent. Well, when you're doing power of a power, you take the two powers and you multiply them. So this is 3 to the 40th, because 5 times 8 is 40. 3, oops. Let's go 3 to the 5th power. Oops. 3 to the 5th power raised to the 8th power. Is that the same as 3 to the 40th power? Yes, it is. We'll talk about what that e means later. This is 7 to the 12th because 3 times 4 is 12. This is x to the 12th because 6 times 2 is 12. This is y to the 40th because 8 times 5 is 40. This is 3 to the 40th. That's interesting. So if you switch the 8 and the 5 around, isn't it? It's 3 to the 8th to the 5th. Same number again. 7 to the 12th because 4 times 3 is 12. Y to the 8th because 2 times 6 is... No. Slow down. Y to the 12th because 2 times 6 is 12. And 1 times 1 is 1, so let's just call it y. Last set of problems here. Use the properties of exponents to rewrite this. Power of a product property. So we're going to raise r to the second power, and we're going to raise t to the second power. R squared, t squared. Get rid of those parentheses. R squared squared, or r squared cubed is x squared cubed is x to the 6th. 2 times 3 is 6. And y to the first power cubed is y cubed. This would be 4 to the 5th, because that's being raised to the first power. We want to raise it to the 5th power. And x to the 5th. We'll go ahead and simplify this. 4 to the 5th, 1024. So let's make it 1024 x to the 5th. This is 2 cubed. X to the 4th cubed is x to the 12th. Y squared cubed is y to the 6th. And z to the 5th cubed is z to the 15th. I'm going to change that 2 cubed to 8. So all I did was take all of those exponents and multiply them by 3, including that exponent right there. There's a 1. That's 2 to the first power. 10 squared is 100. A squared is a squared. B squared is b squared. 100 a squared b squared. 10 squared is 100. A squared squared is a to the 4th. 2 times 2 is 4. And b squared is b squared. Ooh, this is an interesting one. 3/4 squared. Well, what's 3 or 3/4 a cubed b all raised to the 4th power? So we're going to do 3 to the 4th power, which is 81. 4 to the 4th power, which is 256. A cubed to the 4th power, that's actually easier. A to the 12th, because 3 times 4 is 12. And b to the 4th power is b to the 4th power. So 81 over 256, a to the 12th, b to the 4th. Last one, x to the a to the c. What do you do with the exponents? You multiply them by each other. So this would be x to the a times c. Y to the b raised to the c. Again, you multiply the exponents, bc. So x to the ac, y to the bc. Sounds like a really bad rapper. X to the ac, y to the bc. That's long enough. We've talked long enough. So I'm out of here. Good luck. Let me know how it went. See ya.